for using reinforcement learning.
Hello, good evening. So yes, as said, I did a precursor to this talk, shall we say. So as you see, I've updated my slides, and I was looking at a thing called CNN's convolutional neural networks to try and predict cryptocurrency prices. So yes, my name's Matt Hamilton. Some of you possibly know me from around Bristol. I've been a Python developer doing web stuff for about 20 years. I can probably have the dubious accolade of probably being responsible for about half of the commercial web development in Bristol, I think, Python web development. About 1999, started using a very advanced web framework at the time called Zope, that will have half the people running for the fire exit right now. Yeah, it's very strange actually, because I'm actually here from the sort of PyData side of things. So I've never actually been to the debug side. But I used to go along to EuroPython, and I was on the opposite side. So EuroPython, the original EuroPythons, sort of in Göteborg and Charleroi and that, you had a sort of a small group of web people going, well, we could use Python to write some text on a web browser. And then you've got a whole bunch of people who are trying to, like, save the planet and split atoms and sequence genomes and do, like, important stuff. And it was always this weird sort of tension between them. So it's quite interesting to kind of hop, sort of fences slightly. Because I only discovered pandas, last year, and pandas is a library for doing a lot of data analysis, data science stuff. So I now work for IBM, although nothing to do with any of their data machine learning side of things. I actually work with their cloud databases team, so it's sort of a side project. And I've got a personal interest in cryptocurrency trading. So to update you, last time I said that's where the sort of goal of all of this was, is I'm trying to become rich doing this, right? So fairly smart guy, so data science and cryptocurrency, come on, how hard can it be? Really? Come on. And so that's where the plan was. And last time I spoke about an idea I had to try and analyze patterns, what are called microstructures in order books. So when you're looking to buy cryptocurrency or any currency or stock exchange or anything, and you have a market, you have a number of people buying and a number of people selling. And the price is kind of agreed somewhere in between. But somebody will be selling at quite a high price and somebody willing to buy at a low price, and somewhere in between they meet. And I ended up taking a live feed from a cryptocurrency trading platform and mapping out what that might look like. So each one of these squares here is a snapshot in time. I can't remember exactly, it might be about 20 seconds or so, going left to right, each one of them. And the red area represents people willing to sell, and the green area is people willing to buy, or sorry, the amount of orders willing to buy and sell. So we've got this very sort of dark red. That's because cumulatively we've got a lot of people willing to buy, sell, and at the top green there's a lot of people willing to buy. And the occasional blue dots are where an actual trade happens. And that's what the last traded price is as we kind of go along. So you can see this as time goes along. There's certain sort of events, these kind of fissures in the thing. And so I thought, well, could you predict something from that? And could you take that and take that? Okay, so 180 seconds, and say what's going to happen in the next 10 seconds after that? Is the price going to go up or is the price going to go down? And if you work on that really small time frame, there's certain sort of strategies you can use for sort of buying and selling. That's what I talked about last time. I fed that all into IBM Watson's visual image recognizer, the kind of thing that you say, is this a banana or an apple, or is this a cat or a dog? I just fed that into it. And amazingly, it was better than average, actually. The worst thing I was expecting is to come back and say, tell you what, I get this right 50% of the time. But it actually was a bit higher. I can't remember the exact figure off the top of my head, but it was 55, 60% right. And it's like, okay, if you're continually buying and selling, you only need to be right 51% of the time on average to start making money on this. So that was kind of the plan. IBM's Watson visual image recognizer, fantastic. Zip up a file of a whole bunch of cats, upload it, zip up a whole bunch of dogs, upload it, and it will train a classifier, and then you can say, what's this? And it'll tell you whether it's a cat or a dog. So really simple, really easy. So there was a talk, when I gave this last time, this talk, there was a gentleman, Gordon, is he here, Gordon Rennie? No? Okay, correct. So what? No. He did a talk on learning to control an aircraft with what's called reinforcement learning. So reinforcement learning is a type of machine learning in which you have an agent that learns how to behave in an environment by performing actions on observations. So the point being is you just give it a set of rules and an environment. You say, look at this and work out what's what the rules are. Work out what the strategy is given the rules. So there's various examples. You might have heard of things like DeepMind, DeepQ, AlphaGo, the sort of Go playing and chess playing sort of AIs. That's the sort of thing. You have a reward function, which is how many points do you get in the game, and you give it the rules and you go, okay, you work it out, and it'll make a bunch of moves and go, oh, I lost. Make another bunch of moves and go, oh, I did a bit better, and it tries to learn as it goes on. Now, there's a great framework called OpenAI. Project called OpenAI, a framework called Gym. And Gym gives you a defined standard for writing agents and environments. So what's great is you can define your environment, i.e. I'm creating a cryptocurrency trading simulation versus I'm trying to play an Atari game, or I'm trying to teach a humanoid to walk, and you can plug that into a pre-made agent that somebody has written. So the environment defines the rules and the rewards. The agent does the actual learning and chooses the actions. And so very simply, a bit of Python, if you can read it there, you can create an environment, and you can just have a loop, and you can basically say, give me an action, and then do that, and then from that you get back a set of an observation and a reward, and you keep sort of looping around, and hopefully you get better at what you're doing. So there's a package called Stable Baselines, and this gives you a number of agents. So all of these, A2C, ACER, Actor, DDBUG, they're all basically algorithms, sort of state-of-the-art algorithms for reinforcement learning. And they've got different criteria, different things they can do. So some you can use with recurrent networks like LSTMs. These are networks that can learn history and learn what happened previously. If you do 10 things, what's the 11th thing? Well, it knows from the past history what it might be. Some of them can work with discrete inputs. So some of them can work with continuous inputs. So, if I turn left or right, am I giving it a certain amount of left or right in a car on a steering wheel, or is it just literally press the left button, press the right button, and whether they're multiprocessing? So you can take one of these and plug it in. So, for instance, people have used it to try and learn how to play the game Breakout, the Atari. And so the only thing that your algorithm is getting is a set of pixels, just a grid of pixels, and that's its input, and a score. So it gets the score that you've won, a set of pixels, and from there it learns, okay, do I press the left button or the right button? And what's amazing is you can then take that and apply that to any Atari game, basically, that environment. And so people have done that. You can take any Atari game and sort of plug it in, because there's only a certain sort of finite set of inputs that the Atari had, a certain number of buttons. So whether you're playing Breakout or Pong or Space Invaders or whatever, it can learn it. So creating environment, I created one to try and trade, and missing out most of the governance, but it's quite simple what you need to actually implement. A step method and a reset method are the two main ones. And so what happens is you pass that to your agent, and your agent repeatedly calls the step method, and every time it calls the step method, it gets back a series of observations, a reward of whether or not it's done, and some sort of info metadata at the end. So, it's basically, you're training a dog, you ask it to do something, if it does it well, you give it a cookie or a biscuit, right? And it learns that that's the right thing to do. And you keep doing that, and eventually it learns that's, when you say sit, it should sit, it gets a cookie. So same thing, but in Python. We're teaching it to do things. And there's some nice methods, like there's a render method on there that you can say, okay, well, actually give me back an RGB array of what things look like, and I can then, visualize it, for example. So, this is what my environment ended up doing. And this is, anybody who's kind of done anything with sort of trading will recognize it's a candlestick, what's called a candlestick chart. It's the price, it's kind of normalized, so it's within a set sort of bounds there, going up and down. and this is it just going on. So this is what my agent is looking at and trying to learn. Okay, based upon that, what's going to happen next? And I'm doing this using a very visual mechanism, right? I could feed raw numbers to it and say, okay, the price has gone up X% or down X% or whatever. But I thought, real traders look at images like this. So let's just feed it that and see what it does. So this is using, again, a convolutional neural network, which is the kind of thing that can identify patterns and shapes, but then applying it to this reinforcement learning technique. And at the end of it, these are a number of sort of attempts of it trying to work out how it should be trading. And so a green line is where it's traded long. So green, it thinks it's going to go up in price. Red is short, so it thinks it's going to go down. So as you can see here, it really screwed that one up. It thought it was going to go up, it went down. It thought it was going to go up, it went down. It thought it was going to go up, it went down, right? Some of these it did pretty well. Thought it was going to go up, yeah. Thought it was going to go down, yeah. Up, yeah. Down, okay, got that one wrong. That one, yeah, probably right. So, and what was interesting is watching this over time. It ran 10 million iterations on this, over a number of hours, and watching it at the start, and its strategy at the start is very sort of naive, and you see it kind of like, okay, I'm just going to have one go at something, and that didn't work, well, so what? And then after a while, it's kind of learned, okay, if I do this at this point, and this at this point, then it'll work out. So it kind of got there. The end of the day, though, still wasn't profitable on average. So I'm still working on it. I've not got the yacht yet. I'm here talking to you guys. So the future is evaluate the effectiveness of using that sort of image, very visual side, versus passing in raw data. At the end of the day, machine learning algorithms, they're working on matrices of data. Just so happens that those matrices are RGB, pixels. In the case of whether you're trying to work out whether it's a dog or a cat, but it could just be raw numbers. Combine the first approach I had of the market microstructure stuff with a candlestick to give me both a very, very short term and a sort of a longer term kind of prediction, and try and see how that can combine, along with other what are called technical indicators. So there's a whole series of quite simple sort of equations that traders apply that give you things like moving averages, and when one moving average crosses over another moving average, then that means a certain thing. Or if over the last X number of time periods something has happened, then they've got these various, all different. They're all simple sort of statistical analyses of data. But some of them could be of interest here, and you start getting into the weird psychological thing of, well, if everybody thinks this thing is what's going to happen, then maybe that is what will actually happen. So, reading the tea leaves might actually make, it might not be as crazy as it seems, because if everybody thinks that after the 8th successive, time it goes up, it's going to go down, well, then everybody will sell when it gets hit, and maybe the price will go down. So, can it learn that? Moving on, multiple agent simulation. So I'm not trading alone, there's other people there. So other traders, other bots, other algorithms. Can I analyze effectively and learn what they are doing? Can I identify them individually or as a collective? So it might be a case of it works out, well, whenever this happens, then this other agent does something. So I can do something else, and I can kind of learn to outguess them potentially. But I'm not at the yacht yet. So that's where I am now. Thank you very much.
Thank you, Matt.
Any questions? Sorry,
Thank you very much. So, just to clarify, the action the agent is taking is deciding whether to trade long or short.
Oh yeah. Sorry, yeah, exactly. In that case, so here I've defined that the action space is a discrete action space. So it's 3 discrete actions. That is basically buy, hold, or sell. In this case, I did try with a continuous action space, which was buy this amount or sell this amount, have it on a continuous sort of spectrum. The thing with that being is that actually just vastly blows effectively the learning space up massively, and so you need a lot more data to kind of do that. But yeah, so there's, as you see, the action space is 3 discrete inputs. The observation space is, in this case, 0 to 255 is a pixel image of shape 100 by 100 UNA.
So can you say just a little bit about the choice of reinforcement learning as a paradigm there then? Because normally you would pick it as a learning paradigm when your action impacts the environment somehow and changes what you expect to see from the environment coming back. Whereas if what you're doing is just picking an action, you're essentially got a supervised learning problem here, which is
to a degree, but with supervised learning, you have to kind of do your feature engineering to start with. So you have to know what you're sort of looking at. Whereas the point with this is I'm kind of trying to get it to learn what the features are in that regard. So yes, in some ways with reinforcement learning, you're affecting the environment. In this case, part of that environment is actually what my current state is, so how much money I've made and lost. So that is part of the environment. There was a this sort of flashing line at the bottom here is actually a sort of a representation of whether I'm holding one currency or another. So there is some of that kind of encoded in there that is part of the environment. Yeah, fine.
Bit of a question, I'm not entirely sure what I'm asking at all. But if you come across hidden markup models and whether or not they have time component.
A little bit, if I think I know what you mean, and that is that with a sort of a Markov model and Markov decision process, you can see everything, you can see all the states and all the information of the state, whereas a hidden one, I believe, is the fact that you can't quite see all of the information, so you're not aware of everything that you're making a decision on. Have I got that right?
I'm trying to just get back to where the time component is to the convolution of your network.
Yeah.
Because CNNs don't necessarily factor in the time reality, if that makes sense.
No, they don't, but you've got the time reality by by that sort of sample there. So you're looking at it, and at some point in time, does this stop? No, it doesn't. At some point in time, you sort of look at that pattern and go, okay, well, it's gone, up and down and up, and the next thing it'll do is this. So that's kind of representing your sort of time pattern there, using a CNN rather than something like a LSTM or a GRU over sort of a long time period. Go ahead.
So the problem is, what if with that amount, that data coming in, it is kind of random. So unless you feed in sentiment analysis of Twitter comments on Bitcoin or something else that's an actual touch with reality to find a pattern between that, then you could just be dealing with.
This is why I'm not on the yacht yet. This is why I'm not on the yacht yet. So yeah, there is a theory that this is just a second order chaotic system, and there's nothing in there. I can't learn it.
Yeah.
I'm not quite sure. I think there's something
with reality though. So as long as you could find the measure of within reality or.
But the patterns of markets are to some extent directed by news and what's going on.
Yeah,
exactly. So
Oh, exactly. Yes, you can bring sentiment analysis in.
It's not totally chaotic.
No, exactly. No, it's not. I'm slightly being devil's advocate there. That you at one end of the spectrum, you could say it is entirely chaotic and you can't predict it. But I don't think that's right. There are things. The question being is how much of things like news and sentiment analysis is encoded within this data.
Yeah.
So it might be that the sentiment analysis already shows up in this data. So I don't need to monitor Twitter because the data it may already be in there. It may not be. There's different ways of approaching this, and yes, you can do sentiment analysis and things like Twitter. How much that affects, especially if you're looking at so the original stuff I was looking at the time frame of sort of seconds.
But all you need is a kind of like, what is it, a minute trading advantage.
Yep. Yeah. Potentially. It's all an experiment. Like I said, it's why I'm not on the yacht yet. So.
Have you looked at this, like trying to, say, predict sentiment from the data?
Trying to predict sentiment from the data rather than data from the sentiment, you mean?
Yes.
No? Yeah.
Just trying to make some money off trading.
Yeah, exactly. Just trying to make money here. Oh, damn it.
How can we change the sort of visualization style from the CNN? Could you have animated the CNN images you were using in the same?
I could have done those. Those were representing that first lot was representing the kind of the state of the order book and what kind of possible sort of pressure there is to buy and sell, whereas this is what's actually happening in terms of buying and selling. That's why I said in the future I'd like to try and combine both of them and try and see if there's something there of combining both of them and see how it goes.
Thanks for the talk. With the first model that you talked about with the CNN,
Yeah.
you said it was around 60%.
Yeah, I think I got about 60%. I can't remember the
So
exact.
what was the outcome with the reinforcement learning model, like in terms of how accurate it was?
Below 50. At the moment, below 50.
Change the predictions.
Yeah. The problem was that every time I thought I got it right, I realised it was overfitting.
Yeah.
It was on the data that I had, and it was learning patterns that weren't necessarily being, happening sort of later on. And so I think, oh, this is great. It's learned exactly this, and then you apply it to a different currency pair or something, and it goes, yeah, no idea. Sorry, yeah.
Because you bought the yacht,
Yeah.
should the true outcome be whether or not you make a bet based on your model?
Whether or not I get the yacht, feed that into the algorithm. Do I have a yacht or not?
Should the real outcome of the study, because you want some financial outcome of this, be
Yeah.
whether or not you place a bet based on your findings, and if you do train a model which has a satisfactory accuracy, when you therefore make a bet, can you let us know?
Yeah. That's the point. So with supervised learning, you're basically saying, here's a set of data, here's a set of known outcomes, learn the relationship between them. Then here's a set of unknown data. Try and see if you can predict what the correct answer will be. And you get back a percentage accuracy. You're 90% or 60% or whatever accurate, and you're trying to predict accuracy to something. Whereas with the reinforcement learning, you're saying, okay, my goal is. And again, there's a whole other section about reward functions and how you define those. My goal is I want it to be profitable. I want my profit to increase, and that's what it's getting a reward on. So if my profit goes up, it gets a reward, and so it learns that's a good thing. But you also have a function. You also have an issue with what are called sparse rewards. In that if I do something and something and something, and it's a while, I buy some shares or buy some cryptocurrency, and it's a while until I actually sell it. And when I get the profit, all sorts of things could happen in between. It's the same thing that if you tell a dog off for something it did, yesterday, it's not going to know. It's not going to associate those two things.
Can I slightly reframe the question a little bit? I think you're sort of maybe missing my point. The point was, are you going to allow this algorithm to trade your own personal money? That's
Yes.
the point. And if you do, whether or not it's actually making profit or not is the real accuracy of the algorithm. Because they can't
Yes.
see it, otherwise it's academic.
Oh yeah, exactly. Yeah. So at the moment it's trained on historical data.
I won't ever let it touch my bank account.
Yeah.
The really exciting thing is whether or not your person take the risk to actually exploit the algorithm.
I have done with a few of these. Yeah,
Okay.
I have actually done.
Okay.
In most, I'm still here. Yeah. Most of the problems are to do with themes.
Well, you don't turn up to the next one.
If I don't turn up to the next one, that's a canary. Yeah. If I don't turn up to the next one, then look in the financial crimes unit or something. Yeah. It's fees are normally the biggest issue because every time you do a trade, there's a fee, so you have to try and model that fee. In a lot of cases, with this, I'm not actually actively buying a share or a currency. I'm actually offering to buy or offering to sell. So it takes somebody else on the other side of the equation to actually initiate the trade. I'm being what's called a market maker rather than a market taker. So I'm slightly reliant upon other people doing stuff. So it's very difficult to sort of model that. So yes, if you put it live, that's when you start to find out. The problem being is that like I said, I trade that on whatever was 10 million iterations. Well, if I set it live, then maybe by the time I'm 80, it would have learned something. Yeah, if I do it in real time.
Yes. Where do you do this experiment, like live experimentation?
Where do I do it? The one I've got running, various cryptocurrency exchanges, Bitstamp, Coinbase, and the XRP Ledger, the three main ones I've run on.
IBM sponsoring any of your sessions?
No, nothing to do with IBM. They were very. I did get some of the ideas when I went on a tour at IBM Hersley of their emerging technologies lab, and they'd written some AI to predict where football players might move between teams, and that kind of gave me the idea of some of this stuff. And they're very keen to point out that that was not in any way predictions or gambling or anything like that. That was just merely random suggestions that they came up with as a result of computers. So, yeah.
Thank you very much, Matt.
Thank you.
Thank you.